Hi everyone, my name's Louisa and I'm going to be going through an exercise where we're going to apply Ohm's law in a slightly tricky case. So here's the question that we're going to be working on. The first question we're going to look at is the current over the whole circuit, and then we're going to find the current over just resistor 1. So here you can see that our circuit, we have a battery of 3 volts, and then we have two resistors in parallel, one with a resistance of 2 ohms and the other with a resistance of 3 ohms. So let's go ahead and get started on part A of this question and look for the current over the entire circuit. Now we already know that the voltage over the entire circuit is going to be the same as the voltage of the battery. That's to say it's going to be 3 volts, and then we have our resistances of 2 ohms and 3 ohms. So the first thing we want to do is find the equivalent resistance of the two resistors. Now since they're in parallel, we're going to use the equation for resistors in parallel, which is 1 over R equivalent equals 1 over R1 plus 1 over R2, which in our case is going to be 1 over 2 plus 1 over 3, and that's going to give us 5 over 6. So our R equivalent is going to be equal to 6 over 5 ohms. So now we know the R equivalent, and we know that the voltage of the battery is 3 volts. So now we can apply Ohm's law because we're looking at the voltage of the entire circuit and the equivalent resistance of the entire circuit. So we use V equals I times R. We replace V and R with what we know, and we get 3 equals I times 6 over 5. We're going to divide 3 by 6 over 5, so we'll do 5 over 6 times 3 equals I, and we get 2.5 amperes. So that means that the current flowing through the entire circuit is 2.5 amperes. But notice that that's going to be different whether we're going through this or this. The 2.5 amperes is the net current, not the current at every individual point. So now let's move on to part B of this problem. So now we know the voltage of the entire circuit, and we also know the current of the entire circuit is 2.5. And now we're just looking for the current over this resistor R1. So in order to find it, we need to know the resistance of this individual resistor, which we already know. R1 is 2 ohms, and we need the voltage over R1. So in order to find the voltage, we need to apply some of the rules that we know about voltage and current in series and in parallel. So since this is a complete loop that includes the battery, we know that the voltage of this loop needs to be 3 volts. So we've got 3 volts from the battery, and then this is the only resistor in that small loop, which means that it must have a voltage across it of 3 volts. That's the only way that the voltage could start off at 3 here, drop, and then end up at 0 here. So based on that rule, we know that the voltage across resistor 1 is 3 volts. So now we can apply V equals I times R again, and we can go ahead and divide both sides by R so that we can just isolate I, and now we're going to fill in with what we know. We say we've got 3 volts over 2 ohms equals, make sure that you know these are I's, equals I, which is 1.5 amperes. So that's the current flowing through resistor 1. So now let's just take a quick look at resistor 2. It wasn't part of the problem, but I think it presents something a little interesting. Since that is also its own complete loop, we know that the voltage across it is also going to be 3 volts, so we can go ahead and plug it in. We've got 3 volts over 3 ohms. It gives us 1 ampere. So that gives us the current across this resistor. And you'll notice that when you add the current from resistor 1 to the current from resistor 2, you get the current for the entire circuit.